Hiya, so today we're going to be talking a little bit about algebra, what it is, the basic rules, and then go through some examples. So to start us off, what is algebra? Do you have any ideas? As you probably said, it's a letter variable to store unknown values. So in an equation, if you don't know what something equals, you just put a letter as a substitute and then find out what that letter equals. There are three basic rules. So most of the time, especially if the algebraic variable is the same, it's just the normal rules. So addition and subtraction are the same. So for an example, 5x plus 10x, as you probably would know, is 15x. Multiplication, the only thing that's different is you need to pay attention to the law of exponents, which we'll get onto later. But you've got 5g times 10g, you've got the 5 times 10, which gives you the 50. The two g's times together gives you g squared. And with division, it's normal division as well. So you've got, in this example, 9x squared over 3x. You've got the 9 divided by 3, which is 3. And you've got the x squared over x, which leaves you with x. And there's the factorizing and expanding brackets, which is a key concept that you will need to know. A couple of examples. The way I like to think of it is it's just brackets are another way to show multiplication. So in this example, you've got a plus 3 in brackets with 7 in other brackets. And as you can see, it equals 7a plus 21. And for this example, I've shown the 2, but you've got those two a's, which same concept here in the multiplication. You're left with 2a squared. Factorization, on the other hand, so that's expanding brackets, is to put those complicated equations, make them simpler by seeing the like terms, which is just looking at the algebraic variable and seeing if they have the same letters. 15x plus 3, you've got the 3 in common. 3 divided by 3 is 1. 15 divided by 3 is 3. So you can put that outside of the brackets, and then you're left with the 5x plus y. And you've got, for another example, 8xy plus 9y. The only thing that they have in common are the y variable. So you've got your y on the outside of the brackets and your 8x plus 9 inside the brackets. But bear in mind, with every calculation that you do, you remember BIDMAS, BODMAS, which is the order of the way that you do your equations. And you obviously know what each stand for, but just in case you don't, brackets, indices, or operation, which is the little power number that you see, division, multiplication, addition, and subtraction. So you always do subtraction last. Onto some basic types of problems. These are all, especially if you do Edexcel, these are all the type of problems that you will be able to see. We're going to be focusing on just the numerical equations, so that's the number ones and the simultaneous equations, and then we'll go into trigonometry proof, inequalities, and linear equations further in another tutorial. So I've just put these 4 very simple equations to practice for you. And please do the ones on the left-hand side first. These are just showing that you know the basic concepts. And yeah, I'll leave you to it for a few minutes and then we'll go back and sort through the answers. So this first equation here, since the algebraic forms aren't the same, Sorry, just changing the pen color there. You have got 4x plus 4y, so nothing changes there. 12x over 6x, you've got these common variables there, and you've got the 12 over 6. 12 divided by 6 is 2. So you are just left with 2 as the x's cancel each other out. Multiplication example, you've got 5c times 5cy. You've got 5 times 5, which is 25. And you've got 2 c's in your equation there as well. So that's going to be to the power of 2 y. So you don't have any other y variables in that equation. And the last one here, which is a simple subtraction, 10 minus 8, left with 2. And unlike division, you still have those components there, so you need to make sure that you write the right variables, because subtraction doesn't take away these linguistic variables there. And then on this side, you've got ax plus 6x equals 13x. So you need to recognize that 13 must be the answer to a plus 6 equals 13. So you obviously take 13 minus 6 from both sides of the equation, which leaves you with a equal to 7. Does that make sense? Cool. Kind of same for this second example here. Match each to each side. So you've got 3y equals 3y. That's fine. You already know that. And you've got minus 8x to minus 6x. There's nothing else in this equation that contributes to x. So you know that a should equal 6. Be very careful of the signs here. You know that it's 6 because it's minus a is equal to minus 6. So instead of saying a equals 6, could say minus a equals minus 6 to make it clearer. But a equals 6 is the answer. You have a times 3f is equal to 12f. You can see that a does not have an f stored inside of it because the power of f is to 1. There's just an f with no indices or operations to it. So you know that a is just a number. So you look at the 12, you look at your 3, you look at the multiplication. So you know to get a or 3a rather is equal to 12. So to get a by itself, you then have to divide 12 by 3, giving you the answer of 4. Last one before we go. This one here. It's similar to the multiplication, but obviously the opposite way around. You've got your x variables cancelling each other out, which you see here. There aren't any x variables on the other side. And then you know that 24y over g equals 4y. This y here accounts for this y here, so then you know that g is just a numerical variable. You've got 24 divided by 4 is equal to g, which means that g equals 6. And in later questions, we can go through these types of expansion and factorizing questions, simultaneous equations, examples, and then that's it. So take a break and we shall start again after.